This is Enhanced Agility and Simplification the Cloud-Native Way. I'm Wylie. I'm a software engineer. I'm an architect. I'm in DevOps. I'm in GitOps. I write backends in Go. You can find me on LinkedIn, GitHub, and I have a blog. It's caseywylie.io. Nothing special, just some pretty basic stuff, actually. So, Enhanced Agility and Simplification the Cloud-Native Way is about providing software to support lines of businesses that are constantly in flux. So we, as the creators and maintainers of this software, must be agile, must be ready to pivot, must be ready to kind of conform to those changes in the market so we can actually support these lines of businesses. At the end of the day, we can provide much more value when we have the metrics and we have the infrastructure in place. And that's what we're going to talk about today. We're going to talk about how to support the businesses through software. We're going to talk about SDLC. We're going to talk about securing the edge, redundancy, failover, of course, automation, observability, monitoring, alerting, fine-tuning deployments, and very thorough testing. So what is this thing right here? This weird loop. Is it like an infinity loop? Well, to some degree it is. It's a Mobius loop. And there's basically 4 key stages that we've outlined here. And you all have heard plenty about this, but we have a foundational stage where we get our key stakeholders all together in the same room. And we create an environment that's open and collaborative. And we bring those business stakeholders. So if we are concerned with taxes, we're going to bring the tax professionals, we're going to bring the software engineers, we're going to bring everyone together in the same room, and we're going to move on to discovery, and we're going to talk about what the problem is. We're going to ask leading questions. We're going to figure out what is the process right now, what's the problem with the process right now, and what can we do to improve the process. So we start thinking about options. We start spitballing, we're writing things down, we're using Post-its, and we are getting feedback from everyone. Eventually, we shift to our delivery phase, right? So this is constant iterations. At first, we have been listening to the key stakeholders, we've discussed options, and now we're actually starting to chip away at the delivery. Well, what happens after we deliver it? We basically go right back to discovery, and we keep iterating. So this is what we delivered. This is how it's working. Do you see any improvements that can be made? Is this eliminating the problem? Well, let's talk about the options that we can do to actually improve this process a little bit more. And then we're going to kind of deliver that. Now, how does this look? So this is the Mobius Loop, and this is the software development lifecycle. Okay, so we want to make the software development process a continuous feedback loop with communications with lines of businesses opened. We need their feedback. You know, people are hard, numbers are easier. So the people who really understand these problems or having these problems are the business. So we need their feedback, because if we don't know our solution's working, well then maybe we've wasted everyone's time. So let's talk about securing the edge, and we just heard from the folks at Solo who have a very secure edge in Istio. So real agility, how are we able to support these businesses? Well, we're not changing 200 microservices every time a route changes, right? We're offloading work from the infrastructure to the microservices. So this is basically where we're talking about securing the edge, establishing control. We're talking about a service mesh. We're talking about a really good API gateway, and really brownie points for a combination of both. We want to have mutual TLS within the mesh. We want to be able to secure and control routing, change routing, right? /foo is now /bar. Don't change that in your application code. Don't change it across your fleet of applications. Simply change your virtual service, right? Circuit breaking, request transformations, web application firewalls. These are the things we're talking about when we're talking about establishing control of the cluster. Now, everyone's here is professionals. We've worked in the industry, so you take these with a grain of salt and apply them to your own use cases. But pretty much, you can't compromise on security, right? You can't compromise on mutual TLS. we need our certificates, we need our workloads to present certificates that are signed by a common CA. So we want full trust, full control. We definitely don't want people listening to the traffic inside of our networks, right? We need mutual TLS. Also, though, the benefits of a service mesh are realized without changing even a single line of code, right? Because that is just not feasible. That's how you actually fail as a dev shop. You can't expect your devs to go in every time a JOT token needs to change to actually have to leverage the actually application code with that, because applications are microservices that work together. You want to give the infrastructure that responsibility. The infrastructure should be controlling the routing rules. The infrastructure should be doing your deployment, obviously, your blue, greens, and canary deployments. Do not be releasing blindly to your customers. Use blue, green, use canary, use dark releases. Only let a subset of the people watch this new release as it comes out. We want to leverage timeouts and retries. Envoy sometimes fails, right? We can do a retry on to get a lot of power out of that. Also, JOT validation. Let Istio, let Kuma, let's make sure that when foo calls bar, that there is actually a JOT token in the header of that request. If not, don't even send me the request. Don't clog my infrastructure. Now, the reason why you want to be in control of the infrastructure is because errors do happen. You get a call, it's 3 a.m., it's Monday. Hey, something's happening, we're losing thousands of dollars a second. Well, first, I know there's an error. I know where it's coming from. I want you to retry on gateway errors, retry on connection failures, retry on refused upstream, 500 errors, 400 errors, retry on everything, right? Let's get you up and running. Then let's kind of narrow down the scope. Another thing you can do is tiered rate limiting. So maybe in the ingress, maybe in your Kubernetes ingress, you have 60K requests a second, but maybe you have some services that are heavily reliant on databases and you don't want them to receive that much traffic. So that's why there's tiered rate limiting. Maybe you have a cache that can handle a ton of traffic. Basically, we want to rate limit in phases, and we want to rate limit by IP addresses. Is there any reason why one user should be sending hundreds of thousands of requests from the same IP address into your cluster? Probably not, unless you're load testing it. Issue a 429, too many requests, you're blocked out for the next few minutes at least. Or if you have a strong web application firewall, why not just cancel them forever by their IP address? Now, let's talk about failover. So, of course, nothing new. Your data is worth much more than the cost of infrastructure, isn't it? So much more money. Yep. So what are your SLAs? Like, I've normally worked at companies that have very quick SLAs. Like, you don't have much time. When something goes down, you need to get it up. So that's why you need to actually spend some money in order to have a really good, reliable product. So what's going to happen if AWS goes down? Never go down, but anything can go down. So a whole cloud goes down. Are you going to be okay? If a whole region goes down, are you going to be okay? If your hardware fails, will you be okay? There are definitely ways to be okay. So now we're going to kind of talk about automation. So you want to make automation a very regular process. I'm going to give a very quick story, basically about some automation that I built recently. And it was for a distributed database. The task was to have n number of clusters with this database, all connected, sending traffic east to west that is resistant to regional failures, that is resistant to vendor-specific failures. If Google goes down, you still are in AWS, you're still in Azure, you're fine. Also can be deployed on-prem, right? And I said cloud native. Well, cloud native is perfect. I wish everything is in Google or Amazon myself. But in the real world, we have a bunch of people still on-prem, and we have a bunch of workloads on VM still. So it's really kind of, I'm forgetting the word right now, but not exactly cloud native, but cloud like neutral, maybe? Hybrid cloud, that's what I was looking for, hybrid cloud. All right, so we're going to skip to slide 26 for 1 second. So when deployments are tricky, when there is a specific order, right? When I was doing this automation, there were a lot of things that had to happen, right? I had to install this software called Red Hat Advanced Cluster Manager, which manages a fleet of clusters from a single pane of glass, from a single hub. So basically I installed that hub cluster. I then joined all of my managed clusters. I then installed a VXLAN tunneling software, or a way to create VXLAN tunnels is called Submariner IO. Really awesome, but it's a way to do multi-cluster, so we could receive east-to-west traffic between these instances of Cockroach database and always be replicating the data. In your automation, you want to use weights and polling, right? Especially if you're new to automation, you might not understand how almost everything can be automated, and also pretty simply. Devs become really good at automating once they learn Ansible, learn Terraform, learn, I don't know much about Chef, but I do understand that's an automation type framework. But devs will be very good at that, right? They can definitely pick it up. Now you have to support them and give them the patience and the time, but they can totally learn it. So now let's talk about observability, monitoring, and alerting. So why are we monitoring our applications? Why are we trying to identify what's happening and when what's happening, right? Well, say you're going to have a Super Bowl commercial for your company, and you are expecting loads of 60,000 requests a second through your ingress in your cluster at the same time. Well, just because your ingress, maybe it's an Envoy ingress and it's super fast and great, but the rest of your infrastructure may not be able to handle that type of load. So you need to know when 400s are starting to happen. You need to know when 429s, you're getting rate limited. Why am I rate limiting so many people right now? What's happening inside of my cluster? Do I need to actually take extra steps to secure it more because it seems like maybe someone's trying to do a DDoS attack on me? But you need to know, you need to have it transparent. And why? Is this for your engineers? Is this for your devs? No. This is for everyone. This is for the whole business. All of those stakeholders are tying together. We're trying to understand them, they're understanding us, and they are 100% part of the process the whole time. Now, what is so good about monitoring and creating alerts if you're not pushing them through a channel? Right? Like if it's 3 a.m. and my Prometheus instance showing me all these alerts and I'm having all these triggered 400 errors or maybe some 503s happening, well, I need to actually push those alerts through a channel. And that's where Alert Manager comes in, that's where a Slack comes in, because your goal as the engineers are to actually see these problems and address them before they end up affecting your customers. Then your company looks bad, your product looks bad, people start questioning your reliability. If you get in there in time and you see the problem and you can identify that problem, you're very likely to also be able to fix it, especially if you're very familiar with the products themselves. So use alerting. Don't let yourself look bad if you can help it. Secondly, of course, good old Grafana, but we need to be visualizing our metrics also. Not only the engineers, but also everyone from the business. Put these metrics on your monitors in the office. Let the sales team see where we're at, see how many people are using our product at the same time. You know, maybe some of your metrics show which parts of your website people are most interested in seeing. Keep that feedback open. Let everyone know what's going on. And it's your job as engineers to be able to expose it, to be able to paint this picture, and to make it digestible for these business folks to be able to understand, intellectualize. Their brains might work different, but they are very smart in that business, in the business sense. So you need to give them the tools that they need so they can do their jobs. And we need to do our jobs, but we need to work together. Fine-tuning deployments. So obvious, right? Use infrastructure as code. So everything that you need to deploy something needs to be in configuration. It needs to be, and a lot of times, in a repository. But you need very repeatable deployments. So it can be one, deployed by automation, deployed by tools such as Helm, but repeatable, also extremely customizable. You need it to fit your specific use case. You need to assign pod resources. You need to assign security contexts. Deployments. Next, be smart about the deployment strategies in which you're using. Right? Don't be blindly rolling out things to prod. Use blue-green deployments. Use canary deployments where you're releasing just percentage-based deployments, right? Argo rollouts is sweet, right? It can release 10%, start looking at the metrics look good, release 20%, metrics look good, release 30%, until you're all the way rolled out to 100%. Be smart about your deployment strategies. Use Helm charts. Helm charts are super advantageous. They're simple. You can embed a Helm chart inside of a Helm chart. You can roll back entire deployments. You can roll back entire applications, upgrade entire applications in an extremely customized manner. You cannot do that without Helm charts, right? This is an entire application. It's very simple, easy to package, a lot of goodies there if you're not using Helm. Operators, of course, are not for everyone. And long story short, operator is something that's going to control resources in your cluster. Maybe it's going to be looking at your stateful sets, maybe your deployments, maybe your services. But it's just going to actually make sure you have the availability there. And if someone accidentally deletes something, then it's going to replicate that through a reconciliation loop just to make sure that all the components are there. Now, operators do add overhead, and they consume resources, valuable resources in your cluster. And maybe you don't want a cluster that's polluted with operators all over the place. But operators can totally make your life better. Look at that Prometheus operator, right? Have you ever had to manage that long config file, that prometheus.yaml? As it keeps growing, the more alerts you have, the more custom rules you have. It just gets longer and longer. Why not use the Prometheus operator and use a service monitor? Use alerting rules. Create an alert manager config. All of these 3 custom resource definitions files are actually creating that long Prometheus YAML file. Makes it a lot easier. I was going to talk about an etcd app that I made that basically backs up and restores etcd database. Now, for those of you all who know how to back up and restore etcd, you basically have to use etcd-cuddle. You have to send the certificate, the key. You have to give it the endpoints. It's fun, but it's actually pretty boring. So operators can do these manual tasks, right? So I created my operator, which would actually, well, if we're going to get technical, it's going to bind a PVC actually to the node itself. It's going to actually bind it to the master node. It's going to actually communicate directly to etcd. And it's going to have the certificates and keys through secrets and config maps already there. Now I don't have to worry about backing up etcd myself. Now, thorough testing. You build it, you own it. It's yours, right? Like, we all have to take ownership of all of our products and feel pride in them. So a lot of times we just need to help each other, right? Like, maybe the devs aren't as good as infrastructure. The infrastructure people aren't quite as good as development. Like, we all need to come together and actually make our applications battle-proof. So we want one high level of coverage, obvious. A lot of unit tests. Smart unit tests, not just high level of coverage. Smart unit tests that actually paint the picture that says my application is not failing. Integration tests, security scans, penetration tests, load tests. If you're, if you might be getting 60,000 requests a second, 120,000 requests a second through the cluster, you might want to do some soak testing first, because under that kind of load, CPU, memory, everything starts acting differently. So here's where I close. Let's move away from adversarial behavior. Let's all work together. Let's collaborate, and let's collaborate across teams. Let's collaborate with the business. Let's put these Grafana dashboards of metrics, real-time metrics streaming, so our business folks can see it too, so they can make decisions. That's all. Thank you so much.